In the lesson 6.2 example, why do we divide by n minus 1, we'll review the concept of an unbiased estimator. In chapter 1, we learned how to calculate the standard deviation of sample data. We were given the formula S sub x equals the square root of the sum of each x minus the average x value squared divided by n minus 1. Well, what if we divided by n instead of n minus 1? Let's simulate the sampling distributions of two statistics that can be used to estimate the variance of a distribution. Recall the variance is the square of the standard deviation, so we just remove the square root symbol on the standard deviation when we square it. So let's consider statistic 1, where we calculate the variance by dividing by n minus 1, and then statistic 2, where we estimate the variance by dividing just by n. Suppose we had a population where the variance was 25. These simulated sampling distributions are based on 1,000 simple random samples of a sample size n equals 3 from that population. The mean of each of these distributions is indicated by the blue line segment. Our question is to determine whether or not either of these statistics is an unbiased estimator of the population variance. Well, in this section we learned that an unbiased estimator is a statistic that's used to estimate a parameter such that the mean of its sampling distribution is equal to the value of the parameter being estimated. Well, when we look at statistic 1, we note that when we took all of these different samples and then calculated the estimated variance using the formula with n minus 1 in the denominator, we ranged anywhere from a sample variance of close to 0 all the way up to sample variances greater than 160. Most of those sample variances, though, fell kind of in the lower range between about 0 and 60. Likewise, with statistic 2, where we estimated the variance by dividing by n, we saw sample variances ranging anywhere from close to 0 to just over 100. And again, most of those sample variances fell on the lower end here, somewhere between about 0 and 40. Now we note that statistic 1 appears to be unbiased because the mean of the sampling distribution indicated by the blue line here is actually very close to the true mean of the parameter, right around 25. Statistic 2, on the other hand, appears to be slightly biased because the mean of this sampling distribution is clearly less than 25. In fact, it's less than 20 here, so it's underestimating the population variance. Now this is a nice example, too, of why we divide by n minus 1 when calculating the sample variance. We do so because it's going to be an unbiased estimator of the population variance. If we divide just by n, our estimates will consistently be too small, as shown by this particular example. So, for some more practice with determining unbiased estimators, try exercise 1.